The first word problem for chapter 6 says a 84 kilogram boat is initially moving at 15 meters per second. If the wind blows on it for 300 seconds with a force of 650 newtons, find its final velocity. So go ahead and pause, try to solve this word problem, and when you're ready, unpause. Alright, so let's try to solve this. The first number that we have is 84 kilograms. So that's mass. And we have 15 meters per second, so that's a velocity. And we have 300 seconds, which is a time. And we have a force of 650 newtons. So we have 650 N, so that's a force. And we're trying to get the final velocity. So let's just see what's happening. So this is the water, and then you have a boat. The boat has a mass M. And let's see here, the boat starts off moving with the initial velocity V initial. So that's the 15 meters per second. So the initial velocity is 15. And then the wind blows on it for 300 seconds with a force of 650 newtons. So the wind is going to blow on it for a while. And what that means is that eventually the boat is going to speed up to a new velocity, V final. And we're trying to find that new velocity. So this equation is nothing new. It's just force. Well, first of all, there's a force, so you're going to use Newton's second law. Total force is equal to mass times acceleration. And from one of the earlier chapters, acceleration is defined as final velocity minus the initial velocity over time. But you can combine those into one equation that says that the force applied is equal to the mass of the object multiplied by its acceleration, which is the final velocity minus the initial velocity over the time. So I'm going to do it a little bit differently than I have on my picture here, that I have on the side. I'm just going to plug in as is here. So the force is 650 newtons. The mass is 84. We're trying to find the final velocity. The initial velocity is 15 and divided by the time, which is 300. So here you just have to do the algebra and move the terms around. And when you do, let's see what this gives you here. So I can move the 84 to this side. So here it's gonna 84 is gonna go on the bottom. And I can also move the 300 to the others, to the left side. And in this case here, the 300, actually let me just do it on a separate sheet here. So this is the basic formula. So let's just start off by showing how to do the algebra. So it's 84 multiplied by V final minus 15 over 300. So we're trying to get the V final by itself, but there's a lot of stuff in the way. First of all, this being multiplied by 84, so the opposite of multiplied by 84 is divide by 84 on both sides so that they cancel. And next, it's being divided by 300, so the opposite of divide by 300 is multiply. So then multiply this side by 300, and then multiply this side by 300, and cancel. So there what we have is, let's see, 300 multiplied by 650 over 84 is going to equal the final velocity minus the initial velocity, which is 15. And the last thing is that we want to move the 15 to the other side, because it's V final is being subtracted by 15, so the opposite of subtract by 15 is add 15 to both sides. So that it cancels, and so you get that the final velocity is going to be 15 plus 300 times 650 over 84. And that should give you a final velocity of around 2,000 meters per second. So 2.325 times 10 to the 3 meters per second. Okay, so now let's try this word problem. It says, how long would it take for a 1,000 Newton force to change the velocity of a 290 kilogram mass that was initially moving backwards at 600 meters per second, and achieves a final velocity of 1,200 meters per second forwards. So let's just write down the givens. You have 1,000 newtons, that's force, and you have 290 kilograms, that's mass, and you have 600 meters per second, so that's a velocity, and you have 1,200 meters per second, that's another velocity, and it's asking for how long, so we want the time. So let's again try to see what's happening here. So you have a mass m. It's initially moving backwards with the velocity v initial, so backwards is negative. So let's see here, that is going to correspond to the 600. So 600 is actually negative, so v initial is negative. And then a force is applied. Some force is applied. And what the force does is that it causes the velocity to change, so that afterwards the final velocity is equal to 1,200. So then the 1,200 is the final velocity, and we want to find how much time it takes for this to happen. So it's the same equation, just more algebra. So the equation is force is equal to mass multiplied by final velocity minus initial velocity divided by time. And so here I'm going to solve it using variables because there's just a lot of terms to carry around. So we're trying to get time. Actually, this one is actually not too bad, so I'm just going to plug in. So let's see here, the force is equal to 1,000. The mass is 290. The final velocity is forwards, and it's positive 1,200, and minus the initial velocity, and the initial velocity is backwards at negative 600, and that gets divided by time. So if you clean this up some, this is going to be 100 equals 290 multiplied by 1,200 plus 600 divided by t. And to solve for t, just cross multiply. So t is going to be 290 multiplied by 1,200 plus this would be 600 plus 600 and divided by 290, and that should give you around 522 seconds.